Every single programmer knows that feeling, right? That frustration when your program just crashes. But what if those errors weren't actually a roadblock? What if they were more like a roadmap? Today, we're going to learn how to tame Python's errors and exceptions and turn them from a total pain into a powerful tool for building some seriously solid code. Let's dive in. Ah, yes, the infamous wall of red text. We have all been here. You run your code, you're feeling good, and then, bam, a traceback message just like this one stops everything dead in its tracks. Now, it looks pretty intimidating, I know, but it's really just Python trying to tell you exactly what went wrong and where. But what if you could anticipate these moments? What if, instead of just crashing, your program could, gracefully handle the problem, let the user know what's up, and just keep on going? Well, that is exactly what Python's exception handling lets you do. So, here's our game plan. We'll kick things off with the two main types of trouble you'll run into. Then we'll build our safety net with try and except. After that, we'll master the flow, meet the finally cleanup crew, and cap it all off with the pro move, creating our very own exceptions. Okay, first things first. You gotta know your enemy, right? Not all errors are created equal. They basically fall into two big camps: syntax errors and exceptions. And figuring out the difference is the absolute first step to taming them. So on one side, you've got syntax errors. Think of these like grammar mistakes in a sentence. A missing colon, a typo. Python sees this stuff before the program even tries to run and just says, nope, not gonna happen. On the other side, you have exceptions. These are runtime errors. Your grammar is perfect, but something unexpected happens while the code is actually running, like trying to divide by 0 or open a file that isn't there.
So how do we deal with those surprises that happen at runtime? We use a safety net. And in Python, that safety net is called the try-except block. It is a fundamental tool for writing code that doesn't just fall over.
A classic example is getting input from a user. Let's say you ask for a number, but they type out the word 10. If you're not ready for that, trying to do math with the word 10 is going to raise a value error, and your program will crash. This is where try-except is your best friend. It lets you wrap that risky code, try it out, and then catch that specific value error if it happens, all without stopping the program. Let's break down how it works. First, Python runs the code inside your try block. If everything goes smoothly, awesome. The except part is just skipped completely and life goes on. But if an error pops up, Python checks if it matches the kind of exception you told the except block to look for. If it's a match, that except block gets to run. And either way, the program continues on right after the whole block is finished. So here's the bottom line, and this is really crucial. Using try-except is what separates a brittle script that breaks at the slightest problem from a professional-grade application that can handle the messy, unpredictable real world. It builds resilience right into the DNA of your code. Okay, we've got our basic safety net in place. Now, let's level up. We can get way more sophisticated and tailor our error handling for different problems, and even handle code that should only run when things go right. You can get incredibly specific. You can stack up different except blocks to handle, say, a value error one way and an OS error a different way. You can even catch a whole group of different errors in one single block if you want to handle them all the same. And check this out. You can add an else clause. This bit of code will only run if the try block finished perfectly with 0 exceptions. So why would you even use an else clause? It's all about writing cleaner, safer code. See, by putting your success code in the else block, you make sure it's not being watched by your except handlers. This keeps you from accidentally catching an error from code that wasn't the part you were trying to protect in the first place. It just makes your logic so much clearer. Now, sometimes you have actions that absolutely must happen, no matter what. Success, failure, it doesn't matter. For that, Python gives us the ultimate cleanup crew, the finally clause. The whole purpose of finally is non-negotiable cleanup. Think about things like closing a file or releasing a network connection. You want that to happen whether your operation worked perfectly or if it blew up with an error. The finally block is your guarantee. Let's look at the first scenario, the happy path.
We divide 2 by 1 and it works perfectly. So the try block succeeds, the code to show the result runs, and just like we'd expect, the finally clause runs at the end to do its cleanup. This is our baseline.
But what about when things go wrong? Here, we try to divide by 0, which causes an error. Our except block catches it and prints a helpful message. But here's the key thing. The finally clause still runs. Even when we catch an error, the cleanup is guaranteed to happen. Now this is the ultimate guarantee. What if an error happens that we didn't plan for? An unhandled exception that's about to crash the whole program. Even in this worst-case scenario, Python executes the finally clause before it gives up and shows the final error. The cleanup is absolute. It is the last thing that happens no matter what. So far, we have just been reacting to exceptions Python throws at us. Now it's time to flip the script and take control. To write truly professional code, you need to know not just how to catch errors, but when and how to create them yourself. This is all about communicating clearly. The raise keyword is your tool for this. It literally lets you, the programmer, force an exception to happen. You'd use it when, say, your function gets bad data and can't do its job. Instead of just failing silently, you raise an exception to shout, "Hey, something is wrong here." And you don't have to just stick with the built-in exceptions like value error. You can, and you absolutely should, define your own. By creating a new class that inherits from Python's main exception class, you can create custom errors that are way more descriptive and specific to your own program. A really common pattern, like you see here, is to create a base error class just for your project. Then, you can create more specific exceptions that inherit from that, like an input error for bad user input, or maybe a transition error for when your program is in the wrong state. This gives anyone using your code much more power to handle things correctly.
Wow, okay, we have covered a ton of ground here. We've really transformed errors from these scary showstoppers into just another controllable part of our program's logic. So let's do a quick recap of the key takeaways.
So let's wrap it up. You now know the huge difference between syntax errors and exceptions. You can build resilient code with the try-except block, fine-tune your logic with else and finally, and you can take total command by raising and defining your own custom exceptions. You've officially moved from reacting to errors to controlling them. By mastering these tools, you're not just preventing crashes anymore. You're writing code that communicates clearly, fails gracefully, and is truly ready for the real world. That is the power of taming errors in Python. If this explainer helped you out, please do me a favor and hit that like button and subscribe so you don't miss the next one. For more tutorials on Python, you can also visit plus2net.com. Thanks for watching, and we'll see you in the next explainer.